Adrian, welcome. Thanks for joining us.
Made
Adrian
it.
has joined us from East Los Angeles College. Thank you.
Thank you.
Okay. So I think I'm going to start because I have a couple of announcements and we'll let everybody catch up to us all. So for many of you who are on the call, this won't be appropriate for some of the high school teachers, but for all of the college faculty, I think most of you know or are aware of the fact that my job as a regional director, the structure of it may be changing. The vice chancellor up in Sacramento decided that all the regional directors would report to their local regional consortia. So in the Bay Area, that's Rock Fotenauer and Kit O'Doherty, if some of you may know them, some of you may not. And we're in the process of involving all of the college reps and SWP voters to restructure my job. So what we're going to be doing over the next couple of weeks, this is through most of April through June, the various deans and college reps will be presented with data about the different sectors and top codes in the Bay Area, looking at the number of enrollments, the number of completers, job demand, etc. And the college reps will be voting for the various sectors and areas of focus. It doesn't necessarily have to be an existing sector. It could be a new area like apprenticeships or something to do with the formerly incarcerated, or another area of interest is early child care and development, public safety, etc. So this is the time for all of you to really think about your programs. Think about how important automotive is, not only to yourselves or to the colleges, but to your community, to the state at large. And another reason is because we have money. We have SWP money for the next 3 or 4 years. And in the Bay Area, 87.5% of that budget goes directly to the local colleges. So I'd like you, and we've been talking about this, to really think about your programs and what you need for the future. If you're looking at developing new curriculum in ADAS or deepening your skills in electric vehicle, or whatever area that you're going to be focusing on, this is the time to put together that budget, that wish list, and really present it to your deans and to your administrators. Also, if you have valued any of the training you have had the last couple of years or some of the activities that I've been trying to spearhead, make sure that they know that, so that they know that this sector is important to their college and to your community as well. This is the time to do that. We won't know for a couple of months exactly what direction this is going to take. And I'm going to try to be creative and, of course, be a strong advocate for automotive. But if you look at the data, just looking at enrollments, just looking at the different data we're looking at, automotive does not rank in the top 10 areas. So it kind of falls off to about the 15th or 16th area. So we really have to be strong advocates to make sure that this sector gets funded and gets supported at the administrative levels of our colleges and in the region. So if you have any ideas, please let me know. I'm going to be making presentations as I have, and I think automotive has had strong support. I put together 5 regional joint ventures over the past 3 years, and they've all of them have been voted on and approved, funded, and you've reaped the benefit from those different projects. But this is the time for you guys to really think about what you're doing and what you want for your programs going forward, and to make that pitch to those whose votes will be casting the deciding factor for our future. The other thing I wanted to let you know is I did win the proposal that I put forth for the next marketing phase. And I know some of you have seen the new website, and some of you have seen some of the marketing and communication videos that we've put on the various social platforms. But for those of you who have not looked at that, I'm going to show them to you. It has been very important during this time, I feel, with automotive, developing new curriculum, especially all the work we've been doing in the ADAS area and electric vehicles, for students and people in the community to know and understand what we're doing. It doesn't do us any good if we're developing new curriculum and new classes and no one knows about it. And number two, technology is affecting our industry to a very, very large extent, and also the new regulations on emissions. So people are finally kind of waking up to the fact that electric vehicles are going to become a more dominant player on the roads, and that we're deepening our skill sets and upskilling our students and our faculty accordingly. And that was the purpose behind getting this marketing money and getting the communication messages out so that our students and our potential enrollees would understand that our colleges are also changing to make sure that they have the best skill sets available to them for the careers of the future. So I'm going to show you the website just to give you a quick overview for those of you who have not been able to look at it as yet. Oops, I'm going to close it off for now. Great. Oops, leave this aside. So this is the new website that is up. Oops. I hope it's up. There it is. So if you scroll through this, basically we're looking at the future of auto tech, and it's definitely got a message that talks about the new technologies and puts a whole new spin on the automotive careers. The buttons, which are also at the top of the website, give them information about the various colleges. And as you scroll down, you can find a program, a school, or explore careers. If you click on this, it'll open up and show you basically the programs at the colleges broken out by various programs. So auto technician, auto body and collision, diesel, and advanced technologies. So for example, if you clicked on automotive technician, it would basically give you an overview of the colleges that provide those degrees and certificates. And if you clicked on one of the colleges, say in this case, we'll click on Chabot, it gives you an overview of the degrees and certificates at that school. And it gives you a link that takes you directly to the automotive website of the college for more detailed information about Chabot's programs. And this is there for all of the colleges. All of the colleges, we've been working on the content for quite some time. And of course, there's a contact person, typically the chair, co-chair, or automotive program coordinator. And all the colleges are there, and they can search them all out by program. This was a very handy tool for our high schools. I presented this to a couple of the high school and collaborative boards, and they found this very helpful. You can also find a school geographically. And again, if you wanted to look at somebody in the North Bay or somebody down in San Jose, you would just click on the button. It would identify the school, and then you click it open, and again, it takes you to that page with the overview, and then you can click on more details about the college through their website. In addition, you can also take a look at, whoops, exploring the career. And this is where job and salary information is. There's also some videos, and I'm going to click on this is where we're going to be expanding the videos. I'm going to have videos, and I've talked to most of you about this. Some of you have outstanding videos already. This is where we're going to have them uploaded. We're going to have some new videos created, like a day in the life of an automotive tech. What does that look like? And I reached out to a couple of our employers to see if we could do a video, at the DG group, Tesla, et cetera, on site working on their cars with commentary from the employers and some of our alums who are actually working there. So this is going to be built out. Our student success stories, employer stories will be here. But this is a video that I wanted to show you that's actually been playing. Oops. Oops. Let me start this over. So it's only 30 seconds, so you miss a lot. Okay. Great. So anyway, I hope you enjoyed that. You can always go back and take a look at it yourselves additionally, but we played that on various social platforms 6 weeks before during the pre-enrollment period this past semester. The goal was, of course, to build awareness of our automotive technology programs in the Bay Area, the more technology-oriented focus of our programs. And also it was filtered by zip code to help attract underrepresented minority groups and more women. So in the 6 weeks it ran, we wound up with 375 leads. These were people who basically got in touch through the process that we set up with these ads, who were interested in our automotive programs. We then filtered them by zip code and sent those leads to the college faculty to work on to convert to actual enrolled students. Of the 375, 65%, actually almost 80%, depending how you counted it, were from underrepresented minorities and 35% were from women. So our goal for the next semester is to work more closely with the various colleges on the conversion. Obviously, there is interest in our programs. We were very happy with the results, but we really want to work with the colleges to convert those leads into actual enrolled students. And we'll be setting up meetings. I'm going to be sending out a follow-up email to all the colleges in the Bay Area to set up a meeting to work on this strategy, because we also have a new technology. It's called the DRIP campaign, which automatically sets up a procedure that sends out up to 6 emails to each of those interested individuals to keep their interest alive, giving them more information, etc. So we're going to talk about that, and also who on the campus can be a resource for this conversion activity. Anyway, we'll be in touch with more details on that, but I wanted to make sure that some of you had actually told me you hadn't seen it yet. So I promised that I would screen it today. If you have any questions, you can put them in the chat. Oops. And we're going to be talking about that further as we proceed. So I'm going to be sharing my screen with Mike. So Mike, I'll be turning it over to you. And Mike, of course, is going to be presenting his second networks and bus oriented training today. We have 2 more trainings in this group next Wednesday at 4 o'clock. Mike Hernandez from Evergreen Valley College will be presenting his overview of the Tesla Start program from his perspective as faculty. Mike is going to be retiring to our dismay, and sharing with us what he thinks about the Tesla Start program and what our students actually need, what kind of skills they need to work on Teslas, and where our programs perhaps need to be adapted, modified, or revised to deepen the student skill sets to actually work on these more advanced electric cars. And then that following Friday, a week from today, James Lawrence is going to be talking with us about a special project that he did for last summer, looking at electrical, teaching us his students advanced electrical activities on an Arduino kit, which you use as a controller with these electrical boards. And it was a take-home project so that he could actually have the students work on this at home in a safe condition, safe environment. And he then would be teaching them via Zoom while they worked on their electrical kits at home. So I thought it was very innovative, and plus he used the Arduino kits, which was really cool. And this is an idea that even some of the high schools might want to take into consideration, or some of our faculty at the college level. So that's coming up. But in the meantime, let me turn it over to Mike. Mike, could you?
Okay, thank you, Pam. Let's see if I can do this. Hey, does everybody see my screen so far?
Yes.
Okay. Okay. Welcome, everybody. Thanks for joining. Hey, I hope I'm coming through okay. Am I coming through okay? I can always see Pam.
Yep,
Am I coming?
I'm clear.
Okay, okay. Today we're going to discuss as far as the automotive network systems. We'll take a look at bus systems and try to concentrate a little bit more as far as on diagnosis. I will go through this presentation. It contains not only the diagnostic portion, but also some basic things. Just some housekeeping things just beforehand. Number one, thanks again for taking time out on this Friday afternoon. I know it's after lunch and it's like nap time. If you would, please make sure to put your name and your school inside the chat so Pam can keep track as far as who's attending. If you would, please keep your mics on mute, all right? Unless you really have something that you have to say, then go ahead. Post any questions in the chat box. I have some people helping me with them, and we'll stop periodically to answer any questions as far as the chat is concerned, or any questions you might have. I do have the presentation on a widescreen, so you may want to set your slides to see the full screen. And if you have any questions as far as post presentation, make sure go ahead and email me. I'll be happy to try to answer any questions, or heck, if you got barbecuing tips, go ahead and email me those too. Today, as far as our goals are concerned, I know that hands-on would be best, all right, but you know, we're not quite there yet. I know that we're getting close. We're going to try to understand what networks systems are, how to prepare students to understand networks, and then try to prepare our students to diagnose networks. I know that with many of our students, trying to teach them just, you know, how to diagnose a basic 4 or 5 pin relay, how to teach them how to diagnose a coded ground switch, becomes very, very difficult. Now, they have to get into network systems. Network systems is not anything that is really new, all right? Network systems have been around for, what, 25, 30 years now, as far as in cars. So it's something that we really have to start paying just a little bit more attention to, if at all possible. Today is also a time where we can all share knowledge, because I don't know everything, and I don't claim to know everything. And if anybody has any other things that they would like to share, please do. Right now, I'm trying to move this little bar that's in my way. As far as take home, there will be a recorded webinar. I will be presenting the PowerPoint, or giving the PowerPoint, and it will be up on the ATL website. If we haven't been to the ATL website in a while, you can click on the ATL website. It will go to this page. Click on faculty, then click on curriculum. It will give you a drop-down menu, and you can go to Regional Joint Venture Automotive Technology. There will be some new things up here as far as some of the ADAS training that I believe Kurt did. Once you click on that, all right, then you will get into the different presentations. There's zip files. You can download them, steal what you need, use what you want. It's always a very, very good resource to use. As instructors, why rebuild or recreate the wheel when somebody's already started it? Right? Now, as I said before with this presentation, there are a lot of basics in it, okay? And like I said, I'm going to be jumping over some of those basics so we can spend a little bit more time as far as on diagnosis. So every once in a while in the presentation, you'll see this in the corner, it says jump, if you can see that. And all that does is it skips a lot of the basic slides and goes on to actually what I wanted to cover today. So the first thing we'll take a look at is some network systems and how they communicate. As far as we take a look in the first one here, it is just, if you really take a look, it's a 2005. It's a 2005, so that was what, 16 years old, 2005 3 Series BMW. in many cases, we teach our students as far as to, we have inputs and outputs, but a lot of times they're into one control module. An input goes into one control module, it processes it, and then it performs the output. To where with a lot of our vehicles, we're actually getting shared functions, okay, or distributed functions, however we'd like to put that, to where if we take a look at this one, I get an actual, there we go, I get an actual input request from the window switch. It goes into a junction box electronics module, and that's from the passenger front window. The request then is taking over the bus system. As we can see here, it's taking over the CAN bus system, all right, and it actually goes through our footwell module. As far as with the, once it gets to the footwell module, all right, that's the actual module that's going to perform the output, okay, as far as the motor operation. So we have to start understanding that it's not necessarily the control module that receives the input is going to perform the output. A lot of times it's shared functions. Some of them can be easy to figure out, some of them a little bit more difficult, but we're running into more and more. During this presentation, we'll take a look at, as we can see, we have CAN bus systems. All right, there are going to be LIN bus systems or one wire systems, as we can see over here. And we'll also discuss a little bit about the most ring, okay, or most bus diagnosis. As far as bus diagnosis is concerned, I think we all know that vehicles that come in with a bus problem, all right, it's usually quite easy to see, because if an entire bus network goes down, we take a look at the instrument cluster. The instrument cluster looks like a Christmas tree is lit up, because we have so many things that are not working. Or we have sections of the vehicle that just don't work anymore because bus communications are down. Since these vehicles that have bus systems in them are getting to that 20, 25-year-old frame, all right, we're starting to run into the bad connections and things of that nature, or modifications that someone tries or attempts to do. So we'll take a look at bus systems, what happens when they're down, take a look at some signal paths as far as what we need to understand as far as that. Take a look at what's communicated over a bus system. As far as procedures, it's an electrical system, all right, but we're taking a look at the communication portion of the electrical system. We still have shorts to positive, shorts to negative. We can short them together. We can have opens. We can have one wire open. We can have two wire open. All right, all giving a little bit different output as far as possibly a scope pattern, a voltage pattern, or a resistance pattern. At the end, I do want to cover a little bit as far as on fiber optics. As far as fiber optics are concerned, a lot of it used in the entertainment area. And you might think, well, if the fiber optic go bad, we can put in an aftermarket entertainment system, where usually you can't do that on these vehicles, because if we try to put in an aftermarket entertainment system with a system that has fiber optics, in many cases we lose so many things, other things, all right, because we've upset or broken the fiber optic ring, that they're still going to have the old systems in there. Even though I will say fiber optic is possibly a little bit stronger than we might have thought, all right, and also fiber optic can be difficult, but also can be somewhat easier to understand and take a look at, because I can break the fiber optic ring or look at the fiber optic ring at a connection and actually see the red light. I can't see voltage yet, all right, but I can see the red light, so that does help. So we'll take a look at that towards the end. This is a specification sheet that I put in, and I try to get students to look at them just as a quick reference. Most all of this information that's in this specification sheet is in the documentation as far as when you look up the bus system operation and diagnosis for most all vehicles. But trying to get a technician, trying to get a student to actually do what they refer to as read, okay, is sometimes difficult to do. So I do come out with some cheat sheets as far as that is concerned, so they know, what is the scope signal supposed to be for a binary 0 or a binary 1. And with bus systems, we are taking a look at those levels. Are they achieving those levels to give me that binary code? I write down as far as general average voltages that they should see online. And I know that, taking a look at average voltages, does that mean they have communication going? Well, not necessarily, all right, but it is another area to take a look at, right? And then also when applicable, okay, I give them resistance readings. If we take a look, and we'll be taking a look later on at the CAN bus, taking a look at resistance, scope readings as far as binary 1 and 0 and average voltage readings, I usually tell them to do all of them, all right, just to make sure that if you see something wrong, a lot of times making sure you take a look at all of them is a good idea. All right, we'll go into that. All right, so let me start off with just some general signal quality things that we take a look at as far as for readings. Taking a look at a scope pattern, we can see that, we do have lines of communication up and down, all right, and we don't have anything in the center. And that, in many cases, is what we're taking a look at as far as, do I have a good quality bus signal, all right? If they are interfering in this center section in here, all right, then I'm either not going to get a binary 1 or a binary 0, and it's taking apart or taking away part of the message. And if it takes away part of the message, the control module just doesn't know what you're talking about. All right, so that is one thing that we take a look at and try to make sure that they understand. And we can see that here as far as a general pattern. And I'm taking a look at a 1-wire LIN bus, which is a very, very popular bus as far as a scope pattern. We can see that, they give us the, I should be at a roughly system voltage, all right, and it's going to drop down to about 900 millivolts. All right, we can see the small pattern here, and I just have an enlarged pattern over here on the other side. Okay, so yeah, around system voltage, and we'll drop down to about 900 millivolts. That gives me those 1s and 0s.
Mike, can I ask a question?
You sure can.
Okay, what's the relationship between the binary code and the voltage references?
Binary code, okay, so all binary is going to be is just 1s and 0s. That's binary code, right? Bunch of 1s and 0s lined up. And it's usually where it starts off, okay, it's going to be binary 0, and then pulled, this one's pulled down, it'll be binary 0. Okay, so as it reaches each one of these levels, it will give me a 1 or a 0.
Okay, and now and it's like, for example, if the voltage is higher, would the highest be 1 and everything in between is between 1 and 0?
No, I mean it's 1 or a 0. Okay, so on this one, all right, I have a 0, and this is a 1. Now this one's a longer, so there's going to be more 1s in there. Okay, then let's say these here, but it's either 1 or a 0. And it has to pass thresholds. If you take a look at the LIN bus here on this one, your threshold's probably around 7 volts. So as long as it's above 7 volts, okay, and as long as it goes down to below usually 900 millivolts or 1 volt,
those are the perimeters for on and
those
off.
are the perimeters. Now that can vary from manufacturer to manufacturer, okay, slightly, all right, but that's about it.
Understood. Thank you.
You bet. Thank you. Any other questions that we have since we took a pause here? Trying to find out where my chat box is. Any questions out there, Kurt?
No, you're okay.
Okay, thanks. I can't even find the chat box right now. Moving on, all right. Here we take a look at just a moving picture, all right, as far as a good LIN bus signal, all right, moving across the screen. And we can see that, yes, we do have 12 volts, all right? So, you know, it's going above the threshold, 12 volts, and it's dropping down to about, okay, 900 millivolts or about 1 volt. So that one's good. If we take a look at this one, we can see that, well, there's something a little bit different here because 12 volts is actually up here, all right? This one, it looks like a good pattern, okay? But the voltage level is only at about 7 volts, right? But notice your packet frames here, all right, are still long and they still look like the previous one. Here we take a look at another one, okay? And we take a sliding look at this one. We can see that these packets here are actually smaller, all right? And it almost looks like a good pattern. If you didn't have something to compare it to as far as your last one, it might look like a good pattern, all right? But this one, the voltage level is only up to 6 volts, all right? So if we take a look at both of those side by side, all right, this, oops, sorry, wrong place. All right, take a look at this one and this one side by side. We can see that packet size is a little bit different, all right? And if you were to actually see this one on the vehicle, all right, this 7 volt one, right, for the LIN bus was actually working, right? The 6 volt one, was not, all right? Most of the diagnosis or most of the vehicles or the vehicle that I used for most of this, okay, was a 2012 Chevy Equinox as far as the LIN bus. And, you know, on that one, it's a standard LIN to where, yeah, the minimum height that you can have is 7. Anything below that, you can run into problems. And then the low part, all right, should be right around 1 to actually have it possibly work or to have it work, all right? Does everybody follow that? And just when you get this presentation, if you download it, one of the things that I've done, you see a little movie camera here, that means that this will actually be some type of small video clip.
Mike, just to make sure I understand, what we're looking at here is a stream of, well, the networks just constantly going, constantly streaming, if you will. And then if you turn something on, it's gonna affect this pattern that we're seeing.
Yeah, and it will actually, this is constant communication.
Gotcha.
All right. What it's saying, I am not sure. All right. And I don't try to backwards engineer it. All right. I know it's saying something. Sometimes you can flood a network with, you know, signals like rolling up and down windows and you can see more patterns. Okay. But I never try to backlog them to see, you know, what they're saying.
I got you. So this test is just making sure we have the right voltage, and that tells us that we got a good network going.
Right, right. I'm just trying to see if it's getting 1s and 0s.
Gotcha. Thank you, sir.
Mike?
Yeah.
Tom Broxholm had a question. If 7 volts is minimum, what would be the normal expected voltage?
Usually right around 12 to system voltage. I've seen some vehicles regulate, like the first one we saw there, which was at 12 volts. I had a charger on that vehicle, so system voltage was 13.4, but it regulated it down to 12. And I've also seen them to where they've just been whatever system voltage is. Does that answer that, Tom?
And then he asked, should we be concerned at 7 volts?
I am concerned at 7 volts. I am concerned really with anything that's below like 12 volts. All right. At 7 volts, if we have, depending upon vehicle, depending upon charging system, it's barely making communication. You will probably get faults on that one if system voltage drops, such as if we have a smart charging system, okay, that, you know, sometimes it's at 14 volts as far as charging, and sometimes it cuts out the alternator and it's at 12 volts. 7 volts usually is meaning that something's wrong.
What would be some possible causes for that low voltage then?
Usually resistance and grounded, right? In many cases, shorted to ground through resistance.
So are we talking what's that, the 3 most important things here? Does that rule apply? Check the basics, check the basics, check the basics.
Well, yeah, I think we always need to, as far as, if you mean check basics as far as system voltage, I would agree 100% with you. Okay, because I can't condemn what regulated voltage is supposed to be on a bus system if my system voltage is, you know, at 11.
Rick Gridspan had a question. Did you put a resistor to lower the voltage in the slides, or was this a real fault?
This was a resistor. This was just a decade box. All right, and this start hitting the resistances.
That's all we've got in the question so far.
Okay, and you can also reverse that on the power side too. You can get some fun ones going. Okay. So if you take a look at this one, I dropped it down to 5 volts. Now this one I can take a look at, and if we've looked at bus systems before, I can say, okay, hey, this isn't right. All right, something's wrong. All right, so it decays as it goes down. But at 5 volts, it's pretty easy to see that something's wrong with that communication. We get codes when we have problems with bus systems in most cases. We'll get what they refer to as U codes. As far as U codes are concerned, depending upon diagnostic test you have, it can give you, number one, the code, so we can look up the code. It will give you some information as far as if it passed or didn't pass, or if it's fluctuating past. But I still say with aftermarket scanners, the most common description that you're going to get, okay, is it says lost communication. All right, so you have half the vehicle that's not communicating. You take your U codes, all right, and what do you get? Lost communication. So in many cases, the fault is not necessarily directing you to exactly what is wrong. All right, I mean, obviously it's difficult to do, okay, but it just says it's lost communication. Some factory equipment's a little bit better as far as diagnostic codes on bus systems, all right, but in the aftermarket world with the scanners that we have, most of them will say lost communication, right, which is something that you probably already knew, all right? So that's a general LIN bus. Okay, so now let's take that bus information that we have as far as in that one, okay, and take it to a CAN problem that I actually had as far as on the vehicle, right? So we all get, and there's enough information up there that says, you know, what is a good CAN signal? All right, they usually give you a good CAN signal, all right, as far as, you know, voltage should be at 2.5. All right, the CAN high, since it's a 2-wire system, I should go up a volt to 3.5. All right, and then back down, and then as far as CAN low, we should start at 2.5. Okay, drop a volt, go down to 1.5. All right, as far as we might get a little bit of noise every once in a while here, but we will have spikes as far as that's normal, as far as beginning and endings of packets. all right? And we should not have any really cross inside this area here, okay? So we can get our good ones and zeros, all right? So that's in essence what we're looking at as far as to what a good pattern should be, all right? So I'm going to jump over some of the other patterns. We're going to go to a live scope reading that I took, all right? And is this one good or bad? All right, we take a look at, hey, we have a dual channel scope, all right? I am leveling off or starting my signal at 2.5 volts, all right? We take a look at it and by appearance, it looks good. Hey, but one of the things that we can notice here is that it actually goes up to not 3.5, but it goes to 4. Okay, we take a look at the low one, and it doesn't go down to just 1.5, it goes down to, it goes down to 1, right? So even though it looks good, all right, something's wrong with this one, all right? So I took this one and we took it just a little bit further, all right? And I took average voltage. Now I know a lot of people will say average voltage readings, you know, don't really tell you that much about a bus. Well, hey, that's why we take a look at several things. And let's go back to that specification page. With the scope, I did look as far as, hey, the scope pattern should be right around 2.5. Hey, and then for binary 1, it should be pulled to 3.5 and pulled low to 1.5. So I took a look at that on the scanner, all right? And when I took a look at that on the scanner, okay, that did not seem quite right, but hey, it's only being moved, okay, to, as we can see from the previous one, it's only being moved to 4. It's only a 0.5 volt off, okay? It's only being pulled down to 1. That's only a 0.5 volt off, all right? And then we take a look at as far as what are my average voltage readings supposed to be. Can high is supposed to be 2.6. Can low is supposed to be 2.4. All right. And we'll remember the 60 ohms for later on. Okay. So I take a look at my average voltage and average voltage for high. All right. Using a meter. Okay. Since that reads average voltage is 2.9. And the other one's 2.0. So, you know, you might say to yourself, well, gosh, that's not that far off. All right, but that should be an indication to us that something's not right with this one. All right, I will usually tell anybody who asks, okay, if I'm checking a CAN, and let's face it, CAN is one of the more popular networks that we have out there now. If I'm checking a CAN, you know, I will check the scope pattern. If anything seems a little fuzzy with the scope pattern, I will check average voltage, and I will go all the way to resistance, all right, to make sure that everything's okay. So far with this one, I'm being a little bit hesitant about the readings that I've gotten so far.
Hey, Mike.
Yeah.
Rich Donia had a question related to this. Is average voltage for CAN a published spec, or is it what you observed? I've never seen in writing before, although I measure it.
Yeah, no, I've seen it published before. Actually, I've seen it published in all data. Not that often, okay, but yeah, it is published.
That's it so far.
Okay. So
a rule of thumb for average.
That's what I have written down as a rule of thumb, okay, with the specification page. That is an average rule of thumb. I've seen it vary a little bit more from that, okay, depending upon communication level.
Understood. Thank you.
Okay. So then I go to resistance, and I have my ohm meter connected here, all right, and I'm showing 3.8 mega ohms. 3.8 mega ohms, but wait, okay, do I have voltage still in the circuit? Yes, I do. So if I have voltage in the circuit and connect an ohm meter up to it, what happens? Anybody want to say anything on that?
Yeah, it's not good. It's not
It's
the right
not
way.
good, right?
It's not how you use an ohm meter, right?
Right, it's not how I use an ohm meter. It doesn't damage the ohm meter though.
Doesn't tell us anything either.
It doesn't tell us anything. It tells us the wrong reading, okay?
Wrong reading.
Huh? Yeah, it does give us the wrong reading. And that's one of the things that I try to tell students, okay? First thing, as far as with resistance readings, is it has to be isolated, whatever you're checking, and there cannot be any power in the circuit. So the first thing I should be checking, if I know it's isolated, is power in the circuit. If I have power in the circuit and I connect an ohm meter to it, it's going to give me the wrong reading. All right, does that make sense? I've heard a lot of things, and I bring it up every once in a while, that, you know, what happens if I connect an ohm meter to power? And a lot of people say, my meter is now dead and I need to throw it away. Hey, don't throw them away. If you do, throw them towards me. Okay, I'll take any one ohm meter that you hook up to power. So I waited a little bit longer because we have to wait for the vehicle to go to sleep. Communication changed, so my resistance reading changed. Okay, now if you didn't have a scope hooked up to it, you might say, well, gosh, is that the right reading? Okay, so I waited a little bit longer because we know, you know, sometimes it'll take 16 minutes, 15 minutes, half an hour, all right, for the vehicle to go to sleep. Finally get the resistance reading I want. Okay, it's at 61.27. That's close enough to 60. Oh, but wait. Okay, I forgot to do step number one, or I did do step number one, and I still have 2.5 volts on there, right? If I have 2.5 volts going into, hey, my meter, it's not going to give me the right ohm meter reading. Okay, even though I would love to have that ohm meter reading. So I took it one step further to make sure, okay, that everything was shut down. I disconnected the battery. When I disconnected the battery, okay, now I do not have any power in the circuit. All right, when I disconnected the battery, we can see I have 0 volts here, but I have 120 ohms. Okay, 120 ohms is not good. Right? If we remember the specification page, it's supposed to be 60 ohms. I have 220 ohms resistors in parallel, right? So if I have 220 ohm resistors in parallel, I should have a reading of 60 ohms. But with this vehicle, okay, CAN was still communicating, okay? As far as any faults, no faults were present. I've used this vehicle before. I took some readings with it, okay, and noticed that the readings were a little bit off, so we kept on going. This was an actual problem, okay, and I had no faults, and it communicated fine. So now, since I have 120 ohms, I think I have a bad resistor. Now you have to find the resistor, okay, and with General Motors, I mean, their CAN bus is one of their main ones. So we have about 7, 8 control modules that are on the CAN bus. So where is the resistor? Right? So I go to our, you know, let's go to a wiring diagram and see if I can find one. Right? This one was a shop key diagram. Right? So since it was a shop key diagram, I had very nice colors. Okay, I like these diagrams. I like color. Right? But it only showed one resistor, right? As far as the one right here, right? A little bit closer, we can see that it is a data link connector, right? And they even put it down differential support beam. The problem that I run into with this one is if you take a look at this diagram, and it's the computer data line circuits page. It's in 2 pages, and I have students tape them together. All right, but there is so much information on this okay, that you might miss this resistor. All right, so I always tell them, if you can't find it there, let's take a look at some other diagrams. All right, and both Shopkey and All Data will give you these diagrams. Okay, so I looked at the OE diagrams, all right, and I see that, right, using Shopkey, right, no colors, right, but it's okay. All right, it does tell me where the resistor plug is, and the resistor plug is ZZ939. All right, so if I didn't see this on the previous diagram and knew that it was on the differential, okay, I may wonder where ZZ939 is. So I keep on looking, okay, because now it's page 2. All right, and with the page 2, okay, still no colors. All right, I can see the second resistor is at the engine control module. All right, well, engine control module usually is a more published location or control module that's a little bit more accessible in many cases. This one's very accessible. It's right on top of the battery. Fantastic place to put it. All right, so it's up underneath the engine compartment. It's right on top of the battery. So I knew where that one was. Wasn't sure about the other one though. So where is ZZ309 or ZZ939? I did a search. I couldn't find it. So I went to All Data. All right, as far as with All Data, I looked up an All Data diagram, still no colors. You can see that it looks pretty much the same as the last one that we had, except for this resistor is R6. Now, I don't know why one would look exactly the same and be ZZ939 and the other one R6, but I'll take it. And let's go ahead. I did a search for R6, and lo and behold, it told me exactly where it was, and yes, it was on the rear differential crossbar as far as this is concerned, or support. Mine was a front-load drive vehicle, so I didn't have the differential in here. All right, but lo and behold, there it was. I raised it up on the rack, and I could easily check the resistance of that resistor by unplugging it, okay? And it was a beautiful 120 ohms, okay? So, both ECM and data link resistor is 120 ohms, okay? I checked them both. I was taking it at the OBD2, and the resistance that I was reading as far as 120 was coming from the ECM. All right, so I was not reading the rear resistor that was on the cross member. The rear resistor on the cross member has to pass through the fuel pump module. All right. On the fuel pump module, as I can see, some modules have a bypass. The fuel pump module, it actually goes through to read the possible resistor. All right, so bad fuel pump module. One of the things that we had to take a look though, all right, and it's, I guess it's the aftermarket side. Since we are on the aftermarket side, and if we don't have access to factory equipment or their database, we need to look at different software manuals to try to figure out any one given problem. It's basically what's needed, what we're going to have to start getting used to, all right, as far as trying to find information on these types of bus systems. All right. Any questions so far on that? Any comments?
You had a couple of them in there. Backing up a little bit, Richard Donia commented, when I look for 120 ohms plus or minus 20, I disconnect the battery for 10 minutes, like airbag safety procedure. Tom Broxholm chimed in, shorted terminator. And Robert Pinacero said, on a GM car, it's usually at the front and the back of the bus. For example, on an Equinox, one of them is in the ECM. and one is at the rear differential control module. Resistors are there to prevent RFI, so that they want the whole car covered. And then Richard chimed in again, most of the time, one of them is in the ECU. And then Mark had mentioned that MotoLogic has a schematic of this as well.
Oh, okay.
And that's it so far.
Okay, good, good. So good information, great information. And yeah, I guess if I worked for GM, I'd know it's back there, huh? But I had no idea where it was. So yeah, and we have to go back and forth as far as information is concerned. Okay, let me continue on then. Let's take a look at a GM UART system, which is another bus system that GM has. And they have a 5 and a 7 volt UART system. This problem that I had, is I did not have communication on the bus. I had an airbag light on. So let's go ahead and see what I did so far. I show you the airbag light. Here it is. Right, we can see it there, and we also see the information display, a service airbag. All right, most people pay attention to that one. Here I have a 5 volt of what it should be, okay, on a scope, right? And then here's what I got, okay? So I guess I also try to tell students that, you know, you have to get used to looking at these. And every once in a while, since you can't put away your phone to begin with, okay, start taking pictures of these, all right, and put them in a separate file. That way they can refer back to them. So at least I get them to use their phones for something constructive. Here's what I actually got. Okay, and we can see that, well, it's not getting up to 5 volts by any stretch of anybody's imagination. Okay, and it's going down to 0, but I am getting a lot of bouncing. So what did I find? Well, I took a resistance reading, and this one was shorted to ground. Okay, it was shorted to ground, approximately 400 ohms as far as shorted to ground. So now all I have to do, since it has like, I don't know, 12 different control modules on there, I need to find out where. So I thought, I'll look at a diagram. So I took a look at several different diagrams, as we can see. Okay, I took a look at the OE diagrams, all right, and I look at the shop key diagrams. What I was trying to locate here is, I know I have a problem with the bus system. So I'm going to have to go around and inspect the bus system. So I'm trying to find a central location, okay, to where I can possibly disconnect and connect wires, to see what branch of the bus system might be bad. So we took a look first here, and I saw that with the UART system that I did actually have one, and this is where my airbag module was. I did have one splice connection, and it was XJ201. The system also had another splice system, which the airbag was not on it, okay, but it was XJ202. And then if I took a look at the all data or shop key, they still had a they actually gave letter numbers here, but XJ202 and XJ201. So I was able to find junction splices. Okay, so the next thing I said, well, all right, but where are XJ201 and XJ202? Because we know sometimes splices can be accessible, all right, and sometimes they put it square dash in the middle of the dash, okay, to where it's not accessible. All right, so did a small search and found out that XJ201, as we can see here, XJ201, that looks sort of accessible. It looked right out there by the OBD2 connection. So I looked a little bit further, and lo and behold, there it was clipped up underneath the dash, XJ201, even had a piece of paper hanging down telling me, hey, that was XJ201, hey, which was great. Then I took a look for XJ202, all right, just in case I needed it, and found XJ202. Hey, well, it looks like it's by the OBD2 connector, but not sure. Lo and behold, took a few more things, a piece of paper hanging down telling me that way in the back here, okay, by the body control module, I did have XJ202. I was happy to realize that the one that I really needed to take a look at first, okay, was XJ201, which was right out here in the open. And I saw all the green wires going into it, so I knew I had the right one, plus a piece of paper. So what I did, all right, I know that it seems that it's grounded somewhere, okay, but where? All right. It could be that I have a bad control module. It could be that something's wrong with the harness as far as chafing, or connection problem, or connector problem. And what I'm trying to do is I have found a central area. The central area is accessible. And what I'm going to do is I'm going to start disconnecting legs, all right, from that connector. All right, I'm going to start disconnecting legs, and then see if my pattern, all right, restores itself to what a 5-volt UART system should be. Okay, so I got up, let's go ahead and give that a try. I got up underneath there, all right, I found the connector. And it was interesting in this one, as far as these splice points, in some cases, they are just a splice point with several wires going into one area, okay, that is bonded together, all right? And you can use those, okay, but you're gonna have to take apart the factory connection there. Sometimes they're in connection combs, right, to where they're easy or difficult to take apart. This is one of the first time I've seen to where I had the connector and it gave me letters. I was very happy, very surprised as far as that went. Okay, so I set up my scope, all right, and I have my terminal. Right, so the next thing I did is I disconnected a wire from it. All right, once I disconnected the connector from it, using my special tools, I noticed that my pattern came back to what it should be. And I thought, well, this is great. Okay, so I was happy as far as that goes. Now what I have to do is find out where this wire goes. And surprisingly enough, most people will say, well, just follow the wire. Well, I don't know how you're going to follow the wire, because the wire goes up into a loom and it goes up into the dash, okay, and you can't see it anymore. Follow the color. Well, they're all the same color. All right, so that's a little bit difficult also. This one was a little bit easier. I didn't know where it went to because it came out of pin D. But what I did is I scanned the vehicle. I found the control module, airbag control module, was not communicating. Other control modules were now. I did disconnect D at J201, and the bus started communicating, and we saw that in the previous slide. I reconnected it at the J201 connector, accessed the airbag control module, and disconnected the airbag control module. And at that time, the scope pattern was good. All right, so I knew that the wire from the XJ201 to the control module, the wire was in good shape. It only went bad, all right, when I plugged in the control module. So there's something up with the control module. I checked for power and ground to the control module. Okay, it was good. I replaced the control module. I solved problem. All right, so following those, I was able to take it all the way without trying to access every single control module on the vehicle. I know that has to be done at times, but we want to try to avoid that, because if I was trying to access all control modules, it would have taken, I would have had most of the car disassembled on the inside. Okay. Do I have any questions? Comments, concerns?
No. Oh, no,
Good?
you're good. You're good.
Everybody's asleep. That's good. That's good. Is everybody still? Yeah, most people are asleep. Yeah. I know that by when they take their the video off, everybody's usually just sort of. Right. So, all right, we solved this problem. He's my favorite guy, but anyway. Hey, so let's take a look at a most bus system now. With fiber optic systems, I've worked on 2 of them while working with BMW, a media oriented system, okay, which was used for entertainment. And we also used a byte flight, which was for safety circuits. Now, I've been through the training to where, you know, you're not supposed to take fiber optic and wrap it any more or less than the diameter of a Coke can. Be very careful with it, all right, and all of that. And I was a firm believer in that, okay, until we started playing around with some of the entertainment systems, okay, and I would get a fiber optic cable, I put it in line with the system, all right, and we'd all be able to hear music, and then take that same line and tie it into a knot, all right, and we're still able to hear music. So it possibly is a little bit more robust than we might think. I know with the safety circuit also, as far as being a fiber optic, in training, they required us to, with the safety system, is block out one of the wires. So I thought, well, since fiber optic is so delicate, all right, if we just took a magic marker on the end of the fiber optic, okay, and did it and put some black on there, plug it back in, it would not be able to communicate, because they said never touch the end of it. Well, I did that, and to make a long story somewhat shorter, is then I tried whiteout, all right, and it took 2 coats of whiteout, all right. The first coat, obviously putting whiteout on the end of the fiber optic, plugging it back into the control module after it had dried, all right, because you don't want to get it on the inside fiber optic. After it dried, it still communicated just fine, okay? If I put 2 coats on there though, it finally blocked the communication. So it's a little stronger than we might think, all right? As far as the MOST system, all right, it is used in entertainment systems. Right? It usually, as far as a structure, is a ring structure, and a true ring structure, to where this one only goes in one direction, okay? And if one control module fails, in many cases, the entire ring is brought down, all right? This is one problem that usually will come in, usually right away, because it takes away the entertainment system, all right? A customer can drive around with a check engine light on, an oil light on, the tire pressure warning light on, but if the radio doesn't work, they are in immediately, okay, because that seems to be the more important thing to take care of. Everything else can be taken care of with a small piece of tape. Okay, so we take a look at, as far as the MOST bus, and what I'd like to do here is take a look first at a short video that I found. It actually is a Mercedes video, and I found it up on the web, and it goes through diagnosis as far as a MOST bus system is concerned. It does use factory equipment as far as testing it, all right, so that's going to be a little bit different. But then it goes through some tests at the end as far as to look for light or not look for light. And that's mainly what we're trying to do with this system. And I'm going to summarize some of that at the other side of this video. Okay.
Sorry, Mike, before you click, Rich Donia had mentioned Toyota uses a MOST protocol that is hardwired with a single wire. And Mark had commented, how are you going to overpower the squeaks and rattles if your radio can't be turned up?
Okay.
That is fully agreed. That is fully agreed. So yeah, the squeak and rattle control is important. Which reminds me of my father, but we'll go on with that one. Okay, any other questions? Okay, here we go. Hey, don't fall asleep. It's only 6 minutes, okay?
Does it have audio, Mike?
Yeah, it does. Didn't you hear it?
No, you might have to go in to the sharing area and click the play computer audio.
Into the sharing area?
Yeah, same place where you would select what you're sharing.
Yeah.
And there's a little checkbox below those windows that says play computer audio.
Right, and then I have to hit share.
Yeah.
Thank you, Kurt.
Uh-huh.
Let's try this again.
In this video, how to diagnose a fault or break in Mercedes-Benz MOST bus is shown.
That's better.
The MOST bus is the communication bus for entertainment modules in Mercedes-Benz vehicles. When the MOST bus ring fails or a module doesn't relay the message, the other modules on the bus can fail to function correctly. Our subject vehicle had the following fault codes present. U1100 MOST master open. U1102 MOST component at position 1 reports open ring. U1104 MOST component at position 4 reports open ring. U1105 MOST component at position 5 reports open ring. The fault codes have information that can help isolate the possible component or location of the open in the ring. For example, with our subject vehicle, component 1, 2, 4, and 5 are reporting the open. The first step would be to identify all components and their corresponding positions on the MOST bus ring. Begin by identifying the vehicle you're working on. Select Information and Comms. Select Audio, Video, Navigation, Telematics. The control modules in each slot will be checked. On our subject vehicle, each component position is identified. Audio Master, AGW Audio Gateway. Component 1, Voice Control System. Component 2, Navigation Processor. Component 3, CD Changer. Component 4 is skipped and does not show up. Component 5, Command or Audio. Component 6, Sound System. Select Actual Values. Select Actual Configuration of most components. Actual configuration of most components is the pre-programmed fiber optic ring order set by the factory. Unless any after-sales components have been retrofitted, this list should determine the ring order and prepare you for which modules have communication and what the last node to receive the wake-up command would be. Consider this a roll call. Once the roll call is complete, identify the components noted as vacant in red text. These components are expected to be present, indicated by the specified value configuration. When highlighted in red, they did not communicate during the roll call. Components listed vacant with black text are not fitted to the vehicle. On our subject vehicle, we had one vacant slot with red text and 3 components with red text. The vacant slot is component expected to be on bus but not present. The components in red denote out of order but present components. This happens when a component in the roll call doesn't communicate. The missing component here is the navigation unit, which caused the order reshuffle of the present components. With this information, we know to begin our testing at the navigation unit. Gain access to the CD changer and navigation unit. Turn the key on and the radio on. Locate the MOST bus connector at the navigation module. Press the tab and pull the MOST connector straight out of the navigation module. Check the MOST connector for a red light. This indicates the MOST bus light is getting to the navigation module. To check if the navigation module is the module not relaying the data, reconnect the connector. Then, working at the CD changer, press the tab and pull the MOST connector straight out of the CD changer. Check the MOST connector for a red light. No red light is present on subject vehicle. This means the navigation module is not relaying the data. Press the tab and pull the MOST connector straight out of the navigation module. Then, disassemble the MOST bus connector. Release the plastic tabs and separate the connector. Press the blue retainer and pull out of housing. Release the plastic tabs to unlock the MOST fiber optic cables. Pull straight out while holding tabs. Install a MOST bus test loop in place of the module. Turn the key off, wait 30 seconds, then turn it back on. Turn the radio on. Working at the back of the CD connector. Working back at the CD changer connector, check if the red light is now present. If it is, the navigation module is likely faulty. Confirm power and ground to the navigation module are present. If so, the module should be replaced. A quick test for hard-to-access fiber optic cables is to use a laser to shoot light from one end to the other of the cable. This test can be used to test the integrity of a cable that runs through the interior of a vehicle. Disconnect the cable at both ends. Next, shoot laser into the fiber optic cable. The laser will be seen as a red light at the other side of that leg in the fiber optic cable. This test can confirm the integrity of the cable from one component to the next.
Okay, time for everybody to wake up again. A couple of things on that. One was we may or may not have access to equipment that actually accesses the MOST ring. One of the tests that he did, though, as we saw as we went back towards the navigation unit, all right, is that the navigation unit wasn't communicating, and he disconnected and did not see the light, or saw the light and then plugged it in and went to the next module and did not see the light. Remember, it's in a ring. So if we pull it off and we have the key on and we have all the entertainment on just to make sure, we should see that red flashing light. If we don't, we go back to the previous control module. Now, some of the fiber optic lines actually tell you what control module to go to. It will be stamped on the line. Then he went through a test of taking apart the connector. Taking apart those connectors can be done. If you didn't notice it, there was a blue mark on theirs to where I think that was terminal number 1. Light comes in 1 and goes out 2. You have to make sure that they do not get reversed. If they get reversed, you run into problems. So one of the things that we used to do and I've used, all right, are these connectors here, all right? And usually we use the female connectors as far as you can get a loop to where once I had that disconnected, I could just plug this into the end of it, all right? And it would bypass, it would act like bypassing that control module. I went and did a quick search as far as on Google, all right? And this is what I came up with. They're all over the place, and they aren't necessarily that expensive. I am not sure if I would take apart that connector, because if you slip with the screwdriver or break it, you're probably not going to have replacement parts for that, okay? If you reverse the wires, then your system's really going to start getting messed up, and it's going to be difficult to get it back together, all right? So in summary, as far as with fiber optic, if you do have an open in it, we can usually tell by the flashing light, all right? If we don't have the flashing light, we're going to have to trace it back until we do find it, okay? and then possibly bypass that control module. The other thing that you can also get is a large, with male ends on both sides, is a large jumper wire in case you have to replace a wire, or at least run an extension cord, if you will, if you think you have a bad cable. These cables, even though they can be green, they can be orange, they can be yellow. I have seen them cut before with wire cutters. All right, and if they're cut with wire cutters, obviously they don't work. Scotch locks, they don't work too well on these things either. All right, and they usually will damage them. Okay, so with that said, okay, do I have any questions, comments, concerns, or massive complaints at this time?
No, the chat's sitting pretty good, but we should all be worried about the space lasers, according to Mark.
Yes. I use a flashlight. I'm not sure I got it in there.
What, the Navy has pictures now of the UFOs, so it's all good.
Okay, that's all I have for you today. Like I said, this presentation will be posted up on the website. Once I figure out who to send it to and all that stuff. If you have any questions that pop up later on, or any questions about the presentation, please email me. I'll be more than happy to answer any questions that I possibly can. All right.
Great.
Yeah. Can I just say, when I was checking out, because I know a lot of us using Electude and MotoLogic, is for that Equinox, they gave a nice description of all the bus systems too, if you want to read further about that.
Okay, and that was in MotoLogic?
Yeah. Yeah, it was something about description of CAN bus systems, I believe.
Okay, good. Yeah, because that's hard to find at times, very hard to find at times. But then, Mark, how do you get the students to read it?
Yeah, I mean, no, for the rest of us, the instructors.
Yeah, okay.
Right, yeah.
I even give out detailed instructions on students. When you read, start at the upper left-hand corner, go all the way to the right, drop down only one line and repeat, and they still mess up. So I'm not sure.
Well, that's why a scope pattern usually gets their attention, right? Give them something that flashes and is on a screen.
Yeah,
They're used to that.
Yeah. Then they get almost maybe possibly excited. Yes.
Yeah. Thank you, Mike.
Thank you.
John Taylor has a observation commentary. A GM in 1979 used fiber optics to send a rear turn signal lamp or brake lamp to an indicator on the dash. Those would probably make good jumper wires. I like it, John. Great. Well, Mike, thank you so much. We really appreciate.
Thank you for putting up with me.
You put into this and all the hours you spent. It's most appreciated. And as Mike said, I will have both the presentation and the recording uploaded to the atleducation.org website. And all of Kurt's ADAS modules are on the website as well. When you get to the website, just click on faculty and then click on curriculum. And under curriculum, you'll see new ADAS online, and all of Kurt's 10 modules, including the most latest ADAS calibration segment, has been uploaded to that website. So they're all there for your usage whenever it is convenient for you. Great. And if anybody has any other ideas or thoughts about additional trainings for the future, don't hesitate to let me know so we can get that organized and put it together for you. But if nobody has any other questions, I just wanted to thank Kurt, as always, helping Mike out here and helping me out. Appreciate it very much, Kurt. But have a great weekend. Stay safe, get vaccinated, and we'll see you next week.
Thanks, Pam. I was wondering, do you also get ASC training hours for this?
Yes, there are training hours, and I'm keeping track of all of the hours using the reports that are put together by Zoom. So Zoom has various reports that you can download. It tracks all the entrance into a Zoom meeting, for example. if you set that up. And then it tracks how long you've been in there. So I actually can look at it by the second if I want. And I'll be sending out the training certificates for the 4 meetings. I won't do the certificates until after the 4th meeting. And I'll send them out to you as I did last time by email. And if you have any questions or thoughts about that, just let me know.
Oh, and one more thing, just to remind everybody, the CAT conference is also Saturday the 24th.
Yeah, that's coming up a week from tomorrow.
Yeah.
And that's at Evergreen. All right. Congratulations.
Well,
Mark.
virtually at Evergreen.
Virtually, yes, that's true.
Yeah. Thank you, Wendy. And
thank you for all your hard work.
With that, Tom. Yeah.
Great.
And thank you, Pam.
Oh, you're welcome. Oops. I just clicked on something. Oh, Jaime. Bye, Jaime. Jesse didn't get his Tesla training, really? Oh, I have to check on that. I thought this went out. Tesla. Oh, Jamie's still on there. Steve K is still on there. Oops. Jaime has a newborn. He might have been called into duty.
You can close them out from the participant area.
Yeah, put the chat up. Let's turn that off.
Just under remove.
Yep.
Yeah. And then make sure you turn the recording off too.
That's always helpful.